Welcome back to Algebra 1 with Miss Betsy. Today we are finishing up Chapter 8 where we've been working with polynomials. Our final section is dividing polynomials using long division. The text that this video is driven from is this second edition of Algebra 1 published by Bob Jones University Press. If you're using the third edition, make sure that you've got the right video in the right section in front of you. If you're using another text that works just as well, the process for dividing polynomials is going to be the same regardless of what you're using as your school textbook. So, let's go ahead and pray. Father, we love you and we thank you that you are alive and involved in our lives. I ask, Father, that you would help us to learn the material that's placed before us and cause us to be willing to do things that are challenging simply because of the maturity that it works in us. Be with us this day in Jesus' name, amen. Our joke for today, which I promptly lost, okay, how did Benjamin Franklin feel about discovering electricity? Well, he felt rather shocked. And when does your dinner get never hot? When does your dinner never get hot? Your dinner never gets hot if you're having chili for supper. So, dividing polynomials, we're going to introduce this by just working a long division problem, and you're going to see that there are some similarities in doing straight numerical long division and long division of polynomials. So let's go ahead and do this. 1634 divided by 32. 1634 divided by 32. And I'm really glad this is not an arithmetic class because I just assumed not do long division. But we'll do this to illustrate, to demonstrate the similarities between regular numerical long division and division of polynomials. 32 goes into 163. It won't go into 16, so it goes into 163. Let's try 5. 5 times 2 is 10. Carry 1 and we have 16. What are we going to do now? We're going to subtract 160. We have 3. And we're going to bring down our next digit, which is a 4. 32 goes into 34 one time. 1 times 32 is 32, and we have a remainder of 2. And we would write that as 51 and 1/16. But for now, we're going to show this as a remainder because this is what we're going to be doing when we divide polynomials. Now, how do we know that we get the correct answer when we have a remainder? We're going to multiply 32 times 51, 32 times 51, and then we need to add our remainder. So let's see what results. What is 32 times, 51? We have 51 times 2 is 102, and then we have 153. So we have 1,632 is our product of 51 and 32. We add our remainder of 2, and we come up with not 14. We come up with 1,634, which is our original dividend. So we have done our long division problem properly. Now we're going to go ahead and use all of those same principles, dividing, multiplying, subtracting, bringing down the next digit, remainders. We're going to use all of those things when we do this long division of polynomials. So let's clear off this board and see what we have. We're going to be on page 354 in the second edition text, and we have x squared plus 4x minus 9, and we're going to divide by x plus 2. Now the first thing that you're going to notice is that a binomial is a totally different animal from a two-digit number. We divided by what? 32? 32 is a number all by itself. X plus 2 is a binomial composed of two terms. So how are we going to do this long division? Only thing that we're going to look at is the first term of the divisor. We're going to say, what is x squared divided by x? And this is where you have to be able to understand how to do division of exponentials. X squared divided by x is what? It's x, because you have x to the 2 minus 1, which is x. So x squared divided by x is x. Now we're going to multiply. X times x is x squared. X times 2, x times a positive 2 is plus 2x. Now what do we do for our next step in division? We subtract, remember? But we have to subtract this entire binomial. And I always like to put parentheses around this and write your subtraction symbol. That makes it easier for you to remember what's going on. What is x squared minus x squared? That's a 0. What is 4x minus 2x? You have 2x. Now you're going to bring your next term down just like you would bring the next digit down when you do long divisions with numbers. Our next term, we have a negative 9. So we now have 2x minus 9 that we're going to divide by x plus 2. We're going to do the same thing that we did with our first step. We're going to divide the first term of the divisor into this first term here. What is 2x divided by x? 2x divided by x is a positive 2 because those x's cancel. So we have plus 2. What are we going to do now? Well, we're going to do exactly the same thing that we did when we divided by x the first time. We're going to multiply back out. 2 times x is 2x. Positive 2 times a positive 2 is a positive 4. Now we're going to subtract. And before I show you exactly how we subtract here, I'm going to tell you the common error that people are going to do. They're going to say that we have a negative 5 here at the bottom. 2x minus 2x, that we have a negative 5. Not right, because we're not adding. And somehow our brains just sort of do this blip whenever we see positive and negative numbers. So that's why it's important to remember what you're doing. You're subtracting that entire binomial. 2x minus 2x goes away. Negative 9 minus 4. What is negative 9 minus a negative 4? That's a negative 13. Make sure that you do this. Cannot emphasize highly enough that you use this form right here where you show your subtraction sign, put your little parentheses around. Negative 9 minus 4 is negative 13. Way too much chance if you don't write these little visual cues in here that you're going to say negative 9 plus 4 is a negative 5 and completely get your problem wrong. Here or any place where you're subtracting and dealing with signed numbers. Now, if this is going to work in a similar method, similar manner to how long division of straight numbers works, then what are we going to multiply it together? Well, we're first going to show this with the remainder. What is our remainder? It's a negative 13. So what are we saying is the quotient? Well, we're saying that the quotient is x plus 2, remainder negative 13, which even to me, and I'm the math teacher here, that just looks really, really weird. Well, let's see if we ended up with the right answer. How are we going to know if we ended up with the right answer? We're going to take divisor times quotient plus remainder. X plus 2 times x plus 2, and then we're going to add the remainder. And hopefully we're going to end up with the right problem. X plus 2 times x plus 2, we can use that, recognize that by using FOIL, or we can come up with this product by recognizing that we have the square of a binomial. First I'll do this by using FOIL. First terms multiplied together, x times x is x squared. Outside terms, x times 2 is plus 2x. Inside terms, 2 times x is plus 2x. Last terms multiplied together, 2 times 2 is plus 4, plus a negative 13. And let's go ahead and collect like terms. I have x squared plus 2x plus 2x is plus 4x plus 4 plus a negative 13 gives us the negative 9, which is exactly what we were looking for. X squared plus 4x minus 9. So as strange, as weird looking as that answer is, x plus 2 remainder negative 13, that's the correct answer to this division problem. Now earlier I said we could use FOIL, or you could recognize that x plus 2 times x plus 2 is the square of a binomial. So you have x plus 2, quantity squared, plus the remainder, which is a negative 13. When you have the square of a binomial, this is the special product from section 8.7, you square the first term, x squared. You double the product of the terms, 2 times x is 2x, doubled is plus 4x. You square the last term, plus 4 plus a negative 13. Now we collect like terms. X squared plus 4x plus 4 minus 13 minus 9. Whichever way you choose to do this, whether you recognize that you have the square of a binomial or you simply use FOIL to do that multiplication, we have verified that our quotient is correct. Okay? So let's go ahead and do a couple more of these examples. And my, I'm getting dry today. Now if you look in your text on page 355, at the top half of your page gives you a step-by-step written description of how you divide polynomials. Some of you, it may make more sense to look at that. To me, it's easy to get lost in those words, but that is available for you. Let's do our example 2. You know what, it's been really nice to have this magnetic eraser, but it just doesn't erase as well as this old cloth does. Okay, let's see what we have here. We have a long one. We have 2x to the 4th. We have a polynomial. 2x to the 4th minus x cubed plus 5x squared plus 9x minus 6. And we are going to divide all of this by the binomial x minus 1. Now, this is not a quintinomial because it has 1, 2, 3, 4, 5, even though quintuplets 5 kids. This is just a polynomial. It's 5 terms in it. It's a 4th degree polynomial because the highest degreed term in it is 2x to the 4th, which is degree 4. We're going to divide by the binomial x minus 1. What did I say we're going to do always when we do long division? We're just looking at that first term. And that's what the division that we're doing in our head. We have 2x to the 4th divided by x is 2x cubed. Write it out to the side if you need to. 2x to the 4th divided by x. If it helps you to see it or to write the x to the 4 minus 1 is x cubed, write as many steps as you need to. Keep it out to the side. 2x cubed times x is 2x to the 4th. 2x cubed times a negative 1 is a negative 2x cubed. What are we going to do? We're going to subtract, but make sure you put parentheses around your binomial and put your little visual cue that you are subtracting. It will help you. I promise you. 2x to the 4th minus 2x to the 4th. That first term has to go away. If it doesn't subtract out, you've done something incorrectly. Now what do we have? We have a negative. Okay, why did I stop? I thought we've got x cubed, x squared. I did something wrong. We have to have like terms. I have 2x cubed times a negative 1. 2x cubed times a negative 1 is a negative 2x cubed. I'm not exactly sure where my brain went as I was writing that. We're going to subtract. 2x to the 4th minus 2x to the 4th, the first term goes away. Negative x cubed minus a negative becomes plus. Negative x cubed plus 2x cubed is x cubed. Okay, since I just stumbled, let me make sure that I'm fine. X cubed. Negative x minus a negative becomes positive. Negative x plus 2 is a positive 1x cubed. We're going to bring down our next term. Plus 5x squared. Repeat the process. X cubed divided by x is x squared. Plus x squared. We multiply. X squared times x, x cubed. X squared times negative 1 is a negative x squared. We are going to subtract that entire binomial. I've written my visual cues. X cubed minus x cubed, the first terms cancel out. 5x cubed minus a negative becomes plus. 5 plus 1, 6x squared. Now we bring down our next term. Plus 9x. Repeat our division problem. 6x squared divided by x is 6x. 6x times x, 6x squared. 6x times the negative 1 minus 6x. We are subtracting the entire binomial, and we use the parentheses and the negative sign to help us keep track of what we're doing. 6x squared minus 6x squared, our first terms cancel out. 9x minus a negative is plus. Or 9x minus the opposite of a negative 6, the opposite of 6. 9x minus a negative 6 becomes plus. 9 plus 6, 15x. We have another term to bring down. Minus 6. I don't know about you, but this is getting a little bit tedious, isn't it? Yes, it is, and you're going to take a whole bunch of paper, but you know what? Paper's cheap, and if paper's a problem, come see me, and I'll get you some paper. It just is a long process. X goes into 15x. 15 times, so we have plus 15. 15 times x is 15x. 15 times a negative 1 is a negative 15. We are going to subtract the binomial 15x minus 15. First terms cancel. Negative 6 minus a negative 15 becomes negative 6 plus 15 is plus 9. Can you divide 9 by x? You can't. So we're finished with our division. So we have a remainder of 9. Wow, that's a long problem. Did we end up with the right solution? How are we going to check that? Yep, you're going to multiply this times this. You're going to add your remainder of 9. So, let's go ahead and do that multiplication. I have 2x to the 4th. Wrong thing. I have 2x cubed plus x squared plus 6x plus 15 that I'm going to multiply by x minus 1. Remember I showed you earlier that says when you're multiplying you can write from left to right if you wish to. So I'm going to multiply negative 1 times this entire polynomial here. What happens when you multiply by negative 1 or you take the opposite of something? The signs of all of those terms change. So we end up with a negative 2x cubed minus x squared minus 6x minus 15. Now, what happens when we multiply by x? We're going to multiply x against all of these terms. X times 2x cubed, 2x to the 4th, plus x cubed, x times 6x, plus 7x squared. What did I get? 7x squared. I was saying 6 plus 1. Be careful when you do this. X times a 6x is plus 6x squared. X times 15 is x times 15 is going to be plus 15x. Now we add our two partial products together. 2x to the 4th, negative 2x cubed plus x cubed is minus x cubed. We add our x squareds to give us 5x squared. Negative 6x plus 15x gives us plus 9x minus 15. So is this the same? 2x to the 4th minus x cubed plus 5x squared plus 9x minus... Well, what happened here? We have a minus 6. We have a negative 15, a minus 15. What's going on? Do not forget that you have a remainder here. When you're doing division, long division by polynomials, in almost every case where you're just doing long division, you have this remainder that you have to add back in. Plus 9. Negative 15 plus 9 gives us what? It gives us the negative 6 that we're looking for. So we did our long division correctly. Is it tedious? Yes, it is. Do you have to do it anyway? Yes, you've got to do it anyway. Now I want you to notice something. We have x to the 4th, x cubed, x squared, x to the 1st, and this is actually x to the 0. Notice that we have arranged this polynomial here that we're dividing into. It's in descending order by variable, and it goes sequentially 4, 3, 2, 1. You can't have any holes, and you can't have them arranged out of order. And our next problem is going to emphasize that point. Here we have example 3, divide x cubed minus 8 by the binomial x minus 2. X cubed minus 8 we divide this by x minus 2. And this is actually a very special binomial here. In our last section we talked about the difference of two squares. What does this look like? Notice anything? X cubed minus 8. That's actually the difference of two cubes. And there's a special pattern that you can use to recognize that, but you're not supposed to know that yet. Next section, next chapter, you'll learn about that. But for now, let's go ahead and do this long division. We have x cubed minus 8. What we're going to do is put in placeholders. What if we had 1002 that we were dividing by 25? Is that 1002? That's 1002 units. Well, no, we look at that and it's 12 because we have to have the 0 to indicate no hundreds, no tens, and 2 units. So just like you need those 0 placeholders with numbers so that you can identify what's going on, you're going to have to put 0 placeholders in when you are doing long division of polynomials. So let's go ahead and write our problem here. We have x cubed minus 0x squared minus 0x minus 8. Remember what I just illustrated to you where I showed you that in our dividend we were stepping down sequentially and we didn't have any spaces. So now we have 3, 2, 1, x to the 0. Now we can divide by x minus 2. Now I'm going to rewrite this so that I'm in the screen completely. X cubed minus 0x squared minus 0x minus 8. All of that is divided by the binomial x minus 2. Long division of polynomials is always done the same way. You're simply dividing the first term. X cubed divided by x is x squared. And then we multiply. X squared times x cubed. X squared times a negative 2 is a negative 2 x squared. What is our next step? We have to subtract that polynomial, that binomial. We're using our visual cues, our parentheses, and our negative sign to help us keep track of the fact that we're working with signed expressions. X cubed minus x goes away. 0 minus a negative becomes plus. 0 plus 2x cubed, 2x squared, 2x squared. We need to bring down the next term. Minus 0x. We're going to divide again. 2x squared divided by x is plus 2x. Let's multiply and see what we get. 2x times x, 2x squared. 2x times a negative 2 is a negative 4x. We subtract the entire binomial. 2x squared minus 2x, 0 minus the negative is plus. We have 4x. Now we need to bring down our second term. Our final term. Or the second, when I say the second term, it's the second term that we brought down in our division problem. Repeat our long division. 4x divided by x is 4. 4 times x is 4x. 4 times a negative 2 is a negative 8. Now, do we have a negative 16 here? No, your brain is going to want to trick you and make you think that we've got a negative 18 here. Remember, we're subtracting this entire binomial, which is why I put those visual cues in there, which changes this sign. Negative 8 plus 8, we have a remainder of 0. You think, well, that's really weird because you just told us that when you're doing long division of polynomials, that you're going to have a remainder. Typically you do. But remember I said what we have here is x cubed minus 8 divided by x minus 2. That what that was a special, we had a special binomial here. It's the difference of 2 cubes. So it's going to divide evenly. How do we check it? Yep, you got it. We multiply the 2 together. Let's see what happens. X minus 2, x minus 2 times our trinomial x squared plus 2x plus 4. X times x squared is x cubed. X times a positive 2x plus 2x squared, x times 4 plus 4x. Now what do we have? Negative 2 times x squared minus 2x squared. Negative 2 times 2x minus 4x. Negative 2 times 8 is a negative 8. And now we are adding these together. And what do we see happens? We see our squareds terms and our first degree terms cancel out, resulting in our original dividend, which was x cubed divided by 8. So there was another example of long division for you, and I'm not sure that I really see a driving need to do one more problem. Let me take a sip of water and see what I want to do. Let's go ahead and do one more problem just to solidify this for you. And our problem says, this is well worth your time, divide the quantity 3a cubed plus 4ab squared minus 5a squared b plus b cubed. We're going to divide that by the quantity a plus b. This is a very good example. Okay, we've got two variables going on here. How are we going to deal with that? We're going to pick a variable, first one in the alphabet, which is a. We're going to pick the highest degree of a, and we're going to order our set our order in descending order of variable. I'm sorry for the hesitation there. We have 3a cubed, we've got an a squared, minus 5a squared b, we have an a to the first, plus 4ab squared, plus b cubed. All of this we are going to divide by the quantity a plus b. So I can erase my original problem so we don't have that confusing us. What are we going to do? Let's first see what we have here. We have a cubed, a squared, a to the 0 are 1. Let's look at our b terms. B to the 0, which is 1, b to the first, b to the second, b cubed. A lot of the times you're going to see that there's an inverse relationship between the exponents on the or varying. One is going to be descending order of variable, the other will be ascending order of variable. What do we do here when we're dividing by two different variables? Doesn't change the process at all, we're just dividing the first terms. 3a cubed divided by a. 3a cubed divided by a is 3a squared. If you cannot do that in your head, write it out to the side. 3a squared times a is 3a cubed. 3a squared times b is a positive 3a squared b. See, we have like terms. What are we doing now? We are subtracting the entire binomial and we're writing our visual cues. First terms cancel out. Negative 5 minus a positive 3 is negative 5 minus 3 gives us a negative 8a squared b. We're going to bring our next term down plus 4ab squared. When you're working on these problems, you're not trying to teach and think ahead and write on the board at the same time. But still, make sure that you're being very careful to get your transcription correct. You can miss a variable, you can miss an exponent, you can drop a sign, and it's these little picky little things that will cause you problems. We're now dividing 8a squared b by a. What am I going to have next? I think I'm going to have an 8a. I don't mean an 8a. Let's see. We have to have 8a squared b divided by a. 8a squared b divided by a. What do we have that is canceled? One factor of a. Negative 8a squared b divided by a is a negative 8ab. So be very careful. This is just real picky little detail. Negative 8ab times a is a negative 8a squared b. Negative 8ab times a positive b, that's a positive 8ab squared. When you're working with long division that has different variables in it, you know you've got a problem if you don't have like terms lining up. If this had been 8a squared b, I would have known that I had made a mistake somewhere because you're going to have your like terms add up. What are we doing? We're subtracting the entire binomial. Negative 8 minus negative, this first term goes out. 4 minus 8 results in a negative 4ab squared. And I just glanced at the video and I'm really glad this is recording. Negative 4ab squared, I'm going to bring down the last term, plus b cubed. I'm going to take this first term, negative 4ab squared, and we're going to divide again by a. What results? Well, our factors of a cancel, and we end up with a negative 4b squared. Now, negative 4b squared minus a. Negative 4ab squared. Negative 4b squared times b, negative 4b squared. All right? Ha-ha! I'm going to take just a second because we're trying to match this. This plus b cubed here should be a plus 2b cubed. So we're going to bring down a 2b cubed. Okay. Let me see. Okay. You know what? There's real value in me working through this problem in front of you so that you see what I'm looking ahead of is seeing that I'm getting the wrong answer, so I'm having to go back and figure out what my mistake is. Remember when I tell you guys that you've got to do your homework? You have to check your homework, and when you get something wrong, go back and figure out what you've done wrong. Well, what have I done? The problem goes back to here. First, I've miscopied this. But we're not going to worry about that because that's not my only problem. Let's erase this. And check. Make sure that I've done this correctly. Okay, I had a negative 8a squared b divided by a, and I said that was a negative 8ab. Correct. Negative 8ab times a gives us a negative 8b squared. However, negative 8ab times a positive b, what's that answer? Is it a positive 8ab squared, or is it a negative? Remember what I said about being really careful about your signs? And it was when I was telling you to be really careful about your signs that I made a mistake because I was concentrating on teaching. Negative 8ab times a positive b is a negative 8ab squared. Now let's see what happens. We want to subtract this entire quantity. We have our visual cues in. Our first terms cancel, and we now have 4 minus a negative 8, which is 4 plus 8, gives us a 12ab squared. Okay? 12ab squared. We're going to bring down our final term plus 2b cubed. Now what do we have? We have 12ab squared divided by a. 12ab squared divided by a. What do we get when we divide that monomial? Our a's cancel, and we have 12b squared. Positive divided by positive gives us a positive 12b squared. Now we repeat our multiplication process. 12b squared times a is 12ab squared. Write it out to the side if it helps you. Now, 12b squared times b, a positive b, is plus 12b cubed. What are we going to do now? We're going to subtract that entire expression, and I've got my parentheses around it, and I put my negative sign in. 12ab squared minus 12ab squared, those terms cancel each other out. 2 minus 12 is a negative 10b cubed. Can we divide negative 10b cubed by a? Nope, you can't, so we're finished. So our remainder is a negative 10b cubed. Could that possibly be the answer? The solution is 3a squared minus 8ab plus 12b squared, remainder of 10b cubed. How would we verify or validate our answer? We would say a plus b times this trinomial, and then we would subtract 10b cubed. And if you would take the time to do that, you would see that you have the correct answer. You saw that this is, at the beginning, a straightforward process. It may have looked really easy to you. It got a little bit more tedious as you went along. You saw that you have to put placeholders in. Saw what happens with multiple variables. You saw that if you don't copy your problem correctly, you end up with difficulties. Now, could I have gone ahead and done the problem the way it was like I made it up? Sure, I make up problems all the time. But it made it easy for me to catch that I had made an error right here by following the example, since this one was, in all honesty, fairly complex. And you saw that it takes a while to do these. It takes a lot of paper, Do not rush through them. Take your time. Make sure that you understand what's going on, because the skills that you're practicing and that you're solidifying in this section are very, very important to you as you move on to algebra, as you move on through Algebra 1 and on into Algebra 2. So hang in there. I know you can do these. Send me a text or call for help if you need it. And I will see you next time. That had better have been there.